All right, so the second half of this video is to know that once you know that the corresponding parts of congruent triangles are congruent. So if you know you can prove two triangles are congruent, say looking at the sides of the triangles, all three sides are congruent, then you can automatically assume the corresponding angles are also going to be congruent. Or if you mark up two sides in the included angle, so side angle side, then you can assume that the other side and the other two angles are also congruent. So we're going to watch a quick video by somebody else explaining what I just said as well.
If you accept the fact that two triangles are congruent, then you must also accept the fact that CP-CTC must also apply too. But what is CP-CTC besides a geometry teacher's way of knowing for chewing gum? Well, it stands for corresponding parts, so that's the CP, of congruent triangles, I'm highlighting the letters here, are congruent. So what that means is that if you have two things that are the same, every part of those two parts must also be the same as well. Let's look at a quick example to apply CP-CTC. So let's say we had two triangles, where I said, these two triangles are congruent. I'm going to ask you, what are three pairs of corresponding congruent parts? Corresponding means they're in the same position in the two triangles. Congruent because we accept the fact that these two must be congruent. So let's pick out an angle C. If I look at angle C, the congruent corresponding part must be angle F. And how did I know that? Well, there's two ways. One, I could look at A and B and say A has 1 mark, B has 2 marks, D has 1 mark, E has 2 marks. So the only angle in this triangle that doesn't have a congruence mark is F. I could also look at this order right here. That order is very specific. It says if angle C in this triangle is congruent to something in another triangle, it has to be angle F, because C is the third letter and F is the third letter. It asks for two more pairs. Let's talk about this side, BC. So I'm going to say line segment BC is congruent to its corresponding segment in the other triangle, which is EF. And last, we could look at this line segment AC, its corresponding line segment in the other triangle. If I just look at these letters, A is the first letter, C is the last letter. So looking at this one, D is the first, F is the last. I could also look at the drawing to verify that's true. When do we use CP-CTC? Most often in proofs. So if you want to take a look at how to apply it, check out the episode on proofs.
Okay, so that gives us a better understanding of congruent parts of congruent triangles are congruent. So let's look at how we can use that in our proofs. So the first thing I'm going to do is read this given statement. Sorry, I'm doing a video. PR bisects QPS and PR bisects QRS. So when I see that, I know that I can mark this angle being congruent to this angle, and then this angle is congruent to this angle because of the definition of a bisector. And then I want to prove that this side, PQ, is congruent to PS. So that's what I want to prove. But I do know that these two lines in the middle, the line in the middle, excuse me, is congruent for both. So my picture's been marked up. Now let's go ahead. I've got my reasons bank that I'm going to use. So I'm going to start my two-column proof. The first thing I'm going to say is PR bisects QPS. And that was given. The second, so I'm going to cross off given. The second thing I'm going to say is PR bisects angle QRS, and that was also given. So that's my second given. Okay. Well, now I have to define these two angles are congruent. So I'm going to say that angle QPS PR is congruent to angle RPS, and that's definition of bisector. All right, so now I can say the same thing on the other side, that QRP is equal to angle PRS, and that again is definition of bisector. Now I can conclude that, oh, I forgot the side, we have to do the side. So PR equals PR, and that would be reflexive property. Now I can conclude that the two triangles are congruent, so I can say that triangle PQR equals PSR, and that is because of angle, side, angle. Now the last thing I want to do is prove that the two sides are congruent. And now I can do that because I know that the two triangles are congruent, so I can say that PQ equals PS because of C, P, C, and T. C because congruent parts on congruent triangles are also congruent. So that would be my proof for this one. So here we go. Here's another two-column proof that we're going to practice. I've got my reasons bank here. So what I would do if I were you is I would pause the video, try it on my own, and then come back to see if I did it correctly. So let's first go ahead and look at what we're given. So we're given that MO bisects KMN. So that means that I know that that this angle here is congruent to this angle here. And LO bisects KLN. So now I know that this angle here is congruent to this angle here. I want to prove that LK is equal to LN. So I want to prove that this side and this side are congruent. And I'm also going to make one more tick mark right here because I know those two are congruent as well. Okay? So let's go get started. This is going to look very similar to the one before it, even though the pictures look very, very different. So the first thing, MO bisects angle KMN, and that is given. Now I'm going to put in LO bisects KLN, that is also given. Here's my other given, okay? Now I need to prove the two tick marks that I made here on these angles and these two on these angles. So I can say that KML is equal to angle LMN, and that's going to be my definition of bisector. Remember, if you cut something in half, the two sides are going to be equal. Okay, and my fourth statement is that I've got to prove the other two angles. So angle KLM equals angle MLN. And that again is definition of a bisector. Again, if you cut something in half, both halves are equal. Okay, so then the last statement I have to make is I have to prove that LM equals LM. And that I'm going to just use the reflexive property. All right, and now I can prove, because I've got an angle, a side, and an angle, I can prove the two triangles are congruent. So triangle KLM equals triangle. If I start with K, I have to start with N, NLM, and that's ASA, right? And so then the last thing is I have to do my proof, which is that LK equals CLN, and of course I'm going to use CPCTC because corresponding parts on congruent triangles are congruent. So hopefully you were able to work that out. Again, these can be kind of complicated, but the more you practice them, the easier they get. So once again, pause the video and try this one on your own. I'm going to go ahead and get started. My reasons being there is that makes life so much easier. So I know that AC equals BD, that's been marked. I know the measure of angle B and the measure of angle C are 90 degrees. I want to prove that AB equals CD, okay? And I also know that this side right here is going to be congruent. So I'm thinking this is going to be HL because I see a right triangle. So let's go ahead and get started. The first thing I'm going to write is AC equals BD, that's given. Angle B equals 90, given. Angle C equals 90, given. All right, now I'm going to say that side CB equals CB, and that's going to be my reflexive property. So I've used given, given, given. I've used reflective property. The next one I have to say is that triangle ABC and triangle DCB are right triangles. And so it says a triangle has a right angle, therefore right triangle. Okay, so now I've proved that they're triangles. So this is my first statement, second, third, fourth. This is my fifth statement. So my sixth statement, now I can prove that they're using HL because now I know they're right triangles. So I can say that angle ABC equals triangle DCB because of HL. And then the last thing, because I now know that these two triangles are congruent, I can say all their parts are congruent as well. So I can say that CD equals AB, and that's going to be because corresponding parts of corresponding triangles are congruent. This was the part that got a little foggy, and however you word that, that's up to you. Usually it'll be multiple choice anyway. Here are 3 more practice problems. Do pause the video at this time because when you come back, you're just going to look at it quickly. And then when you're done with this, this is going to be your practice for today. Unfortunately, I ran out of time, so I'm not going to be able to show you the third one. But here are the first 2. Okay, so check your answers and raise your hand if you have any questions.